Here we are, background to the KT Boundary and Dinosaur Extinction in Plain English by Brandon Fritz. Woo! First of all, we got to talk about how do scientists study Earth history. What do? They look at there's three eras or time periods. They have what's called the Paleozoic, Mesozoic, Cenozoic eras. Alright, and you can break each of these down into smaller sections called periods. The Mesozoic has 3 periods that we're primarily going to talk about. So we call these the Triassic, Jurassic, and the Cretaceous. And at the end of that Cretaceous period, the rock record, the fossil record, both indicate there was a mass extinction right here. And what went extinct there? The dinosaurs. Rawr! This boundary right in here they call the KT boundary. K for Cretaceous, yeah, I know it starts with a C, it stands for some other things. K is Cretaceous, T is Tertiary. What is a Tertiary? It's that first period of the Cenozoic era. Alright, so there are 3 places in the world where we can go and study rock layers that show rocks and fossils before the KT boundary and after the KT boundary. One of those regions is right here in eastern Montana. Why right here in Montana? Well, for a couple reasons. When Pangea was breaking up during the Mesozoic era, it started in the Triassic period and continued to break up, but then at the end of the Cretaceous period, North America had what was called an epicontinental sea, which is just basically a giant sea that ran down, bisecting North America into 2 parts. And that sea, the on-land sea, about 200 meters thick, expanded and contracted, expanded and contracted. And every time it did that, it would deposit fossils of whatever species are right there. Marine fossils, land fossils, etc. So let's zoom in. We're going to go to Mokashika State Park in Montana and look at... Alright, so here's our sea. And then here we have a tidal region. And that would have gone up over the continental shelf and beach. And here's would have been our land and floodplain. Alright, so here's that sea that's just bisecting North America. And every time it expands, this water is going to go up on shore and it's going to put deposits down. And it's going to show a record of the species living in those habitats. And so what this looks like in Montana is they have labeled these regions the Bear Paw Shale. It's a shale material because, see, the water's standing, you slowly have particles settle out. So you have really small particles creating a bunch of shale. In this high activity regions, we have a lot more sandstone. So they call this the Fox Hill Sandstone region. So tides or sometimes rivers would cut through a beach or an estuary where there's a river connecting like a sea or an ocean and a river on land. So we have a lot more water activity creating sandstone. And this final region over here they call the Hell Creek Formation. So now let's look at each of these 3 in a column of rock layers. Alright, so here are the regions of rock layers that I just talked about. Here's the Bear Paw Shale. That's the oldest. And this there's a ton of marine deposits right here. And it's a shale because it was standing water. And remember, as you go farther inland on the continental shelf and the beach, you have what's called the Fox Hill Sandstone. And again, we find some marine fossils there. As you go up onto the floodplain, we call that the Hell Creek Formation. This is where we find our dinosaurs. See, would have been found right here in the Hell Creek Formation. This whole region is still the Upper Cretaceous. But when you go to Mokashika State Park out there in eastern Montana, you find this coal layer, we call it Z-coal. When you go above that Z-coal line, no dinosaurs. Why? Dinosaurs went extinct. So now up here, this is called the Tertiary period of the Cenozoic era. This is what we call our KT boundary. Right here is where scientists, a lot of them say the extinction of the dinosaurs existed right here. What's the cause? Most would say giant asteroid. But are there other ones? Yes. Let's look at some of those other theories for the cause of the extinction of the dinosaurs. Alright, so what are some of the causes of the extinctions? Majority of scientists will tell you the asteroid theory. Alright, what's some of the evidence for the asteroid theory? Well, like I said, we find that iridium in the clay, in that Z coal. We have a giant crater that's found in just northwest of the Yucatan Peninsula. First one, many scientists agree on the asteroid theory, but there's problems with the asteroid theory. One is the iridium only had 3 samples taken. That's not a big sample size, so it's a little bit controversial. There's also another problem with the asteroid theory, and there's what's called a 3-meter gap. This 3-meter gap is a section below the KT boundary where we find no dinosaur fossils. So the second one is the Deccan traps, or really talking about the volcanic activity. And what scientists believe happened here is we had massive amounts of volcanic eruptions that spewed out a bunch of volcanic ash and dust, blanketed the earth, cutting off sunlight, herbivores, dinosaurs dying out because there's no plants anywhere, and dinosaurs are stressed. What's the evidence? Well, we find volcanic ash in the coal layers of the Hell Creek Formation and the Tulloch Formation there in Montana. We also, a third one is what's called marine regression. This is where the coastal regions along water sources were drying up and water was receding, pulling away from the ocean. Populations of dinosaurs are stressed, dinosaurs died out. This climate change. Some scientists use a combination of the asteroid impact and the volcanism and led to what's called a global cooling, where dinosaurs would have died out. One final one would be the global wildfires theory, where 25% of all plants in the world would have died out, stressing the dinosaurs and causing extinction.